welcome to this review session, and in this video we're going to tackle some basic topics of physics. Okay, let's start. So the first one is solving vector. Scalar quantities are the quantities that are fully described by a magnitude or a numerical value alone, while vectors are quantities that are fully described by both a magnitude and a direction. Some of the examples for scalars are volume, density, speed, energy, mass, and time. Sa vector naman, meron tayong force, velocity, acceleration, displacement, and momentum. So, for example, speed is a scalar quantity, but velocity is a vector that specifies both magnitude and direction. Let's say that a car has a speed of 30 miles per hour. Its velocity is 30 miles per hour east. And then the 30 mph, or the 30 miles per hour, is the magnitude, while the to the east is the direction. Now I'm gonna show you the head-to-tail method. In this method, kailangan natin tandaan na yung mahalaga dito ay yung mga arrow na sinusundan nung head ay yung tail, sinusundan naman nung tail yung head. So, tulad nito. Dito sa example, meron tayong tatlong vector. Vector 1 is 25 meters north of east. Second vector natin, 23 meters 15 degrees north of east then. And then, the third vector, 32 meters 68 degrees south of east. The first thing to do is to draw a free body diagram. Kung i-drawing natin sila isa-isa, ganito siya. This is the x-axis, this is the y. And then we have here 25 meters. And then yung degrees niya is 49 north of east. Ginawa natin yung arrow na mula dun sa may x-axis papunta sa y kasi ang sabi is north of east. And then for the second vector, we have 23 meters 15 degrees north of east then. And then the third vector, 68 degrees south of east. So, ganyan yung free body diagram nilang tatlo. But this time, pagsasama-samahin natin sila dito sa head-to-tail method, wherein magiging ganito yung free body diagram nila. First vector, una natin siyang i-drawing. Let's assume na ito yung 49 degrees. Ito yung head, ito yung tail ng first vector. So, yung tail ng second vector ay ididikit natin sa may head ng first vector. 15. And then yung third vector naman, ganun din yung gagawin natin hanggang sa matapos tayo or ma-drawing natin lahat ng vector. And then for the third vector, remember na makukuha nyo yung resultant dito, lalo na yung degrees, kapag may sinunod kayong scale. Dito sa example natin, walang binigay na scale, pero dun sa mga problem na ibibigay para dun sa may head to tail, karaniwan may scale yun. For example, 1 meter is equal to 5 meter. And then, susukatin nyo lang siya ng ruler. And then, to get the resultant, we're going to draw a arrow again, connecting the tail of the first vector and the head of the third vector. ang maging sagot is 50 meters. And then, yung degrees niya is 7 degrees. Pero kung mapapansin natin dito, lumagpas yung line mula dun sa may x-axis. Kaya, ang direction niya is south of east. Okay, let's go to kinematics. Kinematics is the branch of classical mechanics that describes the motion of points, bodies or objects, and systems of bodies, without consideration of the causes of motion. There are 4 kinematic equations where the initial starting position is the origin and the acceleration is constant. So in this example, we're going to use the formula T is equal Vt, or the displacement is equal to velocity multiplied to time. A car is moving at a constant speed of 40 meters per second. How many hours will it take to travel 200 miles? So we need to take note that we have a speed of 40 meters per second. And the question is, how many hours will it take to travel 200 miles? So using this formula, we need first to convert the 200 miles to meter. So 200 miles multiply to 1 kilometer per 0.614 miles, which means that there are 0.6214 miles for every 1 kilometer, multiplied to 1,000 meter per 1 kilometer. And the answer is 321,853.9 meter. So now we have a meter unit. So to convert it in the unit of time, seconds, we must multiply this with 40 meters per second. So here we have 8,046.35 seconds. To convert it in hours, we will multiply this, the answer 8,046.35 seconds to to 1 minute per 60 seconds and 1 hour per 60 minutes. Then cancel out the similar units, and then we have 2.24 hours. So the answer is time is equals to 2.24 hours. So in this problem, an airplane accelerates down a runway at 3.2 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. So here we need to take note that we have an acceleration of positive 3.2 meters per second. And then we have a time of 32.8 seconds. And then we're finding the value for distance traveled. So the formula that we're going to use is displacement is equal to initial velocity multiplied to time plus 1/2 of acceleration multiplied to time squared. And then we have here the acceleration, the time, and the initial velocity is equal to 0. So we can solve it now. Plug in the values for this. We have the answer is 1,720 meters. The displacement is equal to 1,720 meters. For the next topic and the last one, we have the circular motion. So here are some of the formulas for the circular motion. Circular motion is the motion of a body following a circular path, and then it has a force that acts on the body moving in that path and is directed towards the center, and it is called centripetal force. For example, a 0.5 kilogram ball moves in a horizontal circle of radius 1.5 meter at a speed of 30 meter per second. What is the centripetal force acting on the ball? So here we have a mass of 0.5 kilograms. We also have its radius and the speed. We are looking for the value of centripetal force, and the formula for that is centripetal force is equal to mass multiply the velocity squared over its radius. So all we need to do is substitute the values. And the answer is 300 Newton. For the last example, we have a 0.35 kilogram ball is attached to a rope moving in a horizontal circle of radius 85 centimeters. If the rope can withstand a maximum tension force of 1,500 Newton, what is the maximum speed that the ball can travel in this circle without breaking the rope? So we have here 0.35 kilograms as our mass, radius of 85 centimeter, and a tension force of 1,500 Newton. In this example, we are looking at the speed. But what is the formula for speed? So if we're going to derive the formula for speed using the centripetal force formula, centripetal force is equals to mass over v squared over multiple to v squared over radius. And then we have v squared is equal to radius multiplied to centripetal force over mass, or then we have speed is equal to square root of radius multiplied to centripetal force over mass. So again, plug in the values. The value for speed is 60.4 meter per second. And that's it. That's all for our review session. Thanks for watching.